So I'm back again. This is part of the series of lectures on how to make an enclosure for various types of electronics, what do you call, projects, instruments or designs. As I have told you before, the concept probably starts in your mind saying this is what I'd like to have in the end. Even what you have in the mind may be something which has started a little earlier or has been there for a long time. One is when you have a focused what do you call requirement, somebody says I want a proper controller for my air conditioning in the house. I think some of you must have also felt it. Most split ACs which show a time or the temperature which is there, either they show you the set temperature or they show you temperature of air that is coming in or air that is going out. Very rarely about the actual temperature in your immediate surroundings. So now let's say you set about making it and then you are reasonably thorough about your electronics and various things. Now you need to put it into an enclosure or build an enclosure which is aesthetically pleasant, that is somebody would like to buy it, and it will also show you what the current temperature is and then what the set temperature is. So obviously you need to start with a model, and it could be a sculpted model made out of foam, or it could be a cardboard model similar to what I have showed you earlier, or in the very initial stages it can be just a nice enclosure in which you can put everything and try it. Eventually somebody else, a designer, will convert it into a designed product, as in design. So far I have covered a lot about how to give what do you call IP protection and how to select connectors and all which will make things inside outside, and a little about safety and then how to make sure that the temperature and all, we have separate issues with it. Starting from the last lecture, I thought because of the partly repetitive and partly what do you call calling on earlier experience and various hardware, we have to start using computer aided design software. Again, as I have told you earlier, simple 2D has always been related to either mechanical or construction, civil construction and drawings, and then part of it was used to convert 3-view engineering drawings to make them useful for machine operations in the fabrication shop, including sheet metal. And then parallelly, illustration and other 3D solid modeling software have developed to make products which are properly aesthetically designed. So if I take a thing, I keep showing you this mouse because it's a handy object, not easy to get to where they have got. Tough. Tomorrow I will try to bring you a very narrow mouse. If you can now follow the monitor. Yes, CAD anyone? No, CAD everyone. There is nothing like it. It's a rhetorical question. Including all over the world, people are trying to convert existing what you call archived things into a digital format. Simplest was you scan it and just store it, saying someday this backup will be useful and someday software may come which will read these lines and then try to convert it into a digital format. Simple. When they say digitization, it is about storing archival information in a digital format, which happened with books, which happened with popular things like the National Geographic. We went and bought a huge National Geographic collection, and it turned out it's scanned and not that very readable in the old format, but still I like it because I can read it. Now things have changed a little now since then. First thing is, You can read it along with me, and each point I will try to elaborate little. One of the first thing is they're supposed to make things easy. Thing is, making things easy is full downstream, all the way down, including upgradability. Later on, if you want to change one feature, in the earlier lecture I have covered about so-called bidirectional associativity, that if you change the dimension, the feature representation changes. If I change the representation, that is, if I change the radius, automatically dimensions get updated. So the last one is, it looks a little complicated, saying, no, are we not making it complex to make it simpler? Yes, it is like this. You have no choice. If you want to use a coffee maker, obviously the simplest way is you mix some what you call cafe soluble in milk or water and drink, and then maybe you heat it. The moment you want to make next level, you need to make put powder into something and add water, and then it filters, and then you have so many of them, including cafe espresso and so on and all that. The last point is probably they're complicated, but then it tastes much better. So let me get out of that what you call allegorical representation and go back to the thing. First of it is accurate representation of features. Main thing when we talk about representation, when we call a line saying this is going to be 75 point something something, 76.2, it will be 76.2, and then the advanced software will also add a tolerance on the dimension. So if I have two openings, like you can see here, you can see, luckily for me on the screen, you have an opening here, that's probably via a hole of a PCB, and across I have one more opening here. Imagine if I now tie these dimensions, depending on the fabrication and depending on the tolerance and all that, most XY machines obviously have a horizontal X coordinate system, and then similarly we have a Y coordinate system, and then there is a resolution and what can be achieved by the machine. Now imagine I have some mounting holes and there is a tolerance associated with it. This has to match in ordered conditions. And sometimes it is expensive. In fabrication it may be expensive, but in the case of a drilling in a printed circuit board, already the resolution is as high as we expect. So we can keep the printed circuit board, this whatever it is, no, you have a feature here, then, which way I am moving out? Okay, let me take it out from here. I have a feature there, then I have a feature there. These features can all be tied together, and then generally the printed circuit board tolerances are much tighter. Now if you have to go and sit onto a, let's say an enclosure onto 4 spaces, it will sit nicely. This is where the accurate representation of features issue comes. We have the next level. If you have seen all the connectors and all which we have checked about, all of them come with a dimension. All of them come with also tolerances on the dimensions and also specifications of what should be the mounting holes. I have given you example of the connector which is mounted with a flange with 4 openings. Then I also given something which has got a bulkhead mounting, that is a D type of mounting. These features comes easily in the case of CAD, where you can build, library components. So if you look around your thing, you will be a specialist in one area. So when you are a specialist in one area, you use one set of components and all that which have been tried, tested, and probably type approved. So you have a beautiful library which you can use in your fabrication, and electrical or the what do you call technical electronics engineers can use the other characteristics of it. Now if you see, we come to the next thing about sizes, openings, radii and all these. One is the desirable thing what we want. Understand, the designer wants something. The other is what is economically feasible in the fabrication shop. So once we standardize all these things, it is very easy for us to play around with rather rearrange things. Something a little related to this is scaling. If you see most standoffs, fasteners, hinges, all these follow certain proportions. If it's a 3/4 inch, 19 mm hinge, it has certain proportions, next it's something and so on like that. And if you take things like metric screws, for that matter any screws, you have a nominal screw thread and a nominal pitch. All other proportions are related to this nominal screw end pitch. Most CAD programs allow us to scale up these drawings without any problem. So you can keep the screw as it is and then make it a little longer. Typically if you take a M3 screw and then you, let us say you have started with a 10 mm nominal dimension. If something goes wrong, you can always reduce it to 8. Similarly, you can increase it to next higher level, which determines the height of all other features of your product. And main thing is ability to duplicate things which have created already is the height of these things. Towards the end I have a sample, I will just show you how we have achieved it. So when we talk about duplicating is the core, only at one place you need to probably give the necessary openings. The most advanced software allows you to change the whole lot at one place. You just type in the new numbers and everything gets changed everywhere. But it leads to a little bit of confusion, and then people like me are not that familiar with the most advanced software. We find it a little tough to deal with it, but it's very easy to learn. If you know one, you know all. So you can exchange library components across other professionals. You need not be tied down saying I need to meet the other person to see what he's using. You just need to get the information by data exchange, and then you have a library, and then you can restrict this library component. So if I am talking about a BNC connector which has certain connection at the back of it, the front part of it is standardized. At the back you can have a solder pot, or you can have a crimped thing, or you can have, I do not know, one more adapter at the back across the bulkhead. All of these can be standardized. And related to this itself is the online availability. I have shown you examples of the standard enclosures where all the information is available online, with of course a little small this thing saying information usually is not, at least the one that is not contractually accepted, is not updated so frequently. So if you want any updating of it, or in our case you would ask something saying I do not want this 1/4 inch UNF screw, or 1/8 inch, I do not know such a thing, 1/8 inch UNF I do not want. If instead I would like to use an M3 screw. So material you receive may be in the modified condition, but the catalog still refers to the old condition. This is where we need to update our library. And we'll come to the last thing. Slowly we'll notice that complexity is increasing. It looks oxymoron, how to make something easy complexity, or complex ease with which we solve problems. Main thing is downstream production or economic producibility is the focus. First of all, everything matches perfectly. Everything, just about everything matches perfectly. Input is from nebulous concepts in the mind. Somewhere, as a stroke of, I won't call it madness, inspiration, you would have got an idea saying, I require this feature in the new product. So from there, using CAD very easily, you can convert it into actual specifications and dimensions. So let's say you have a remote control, and then you need to put a joystick on the remote control. So it's easy. Now all the upgraded TVs, now what you get, already have a provision for connecting it to the, I mean, I'll use a word like internet, please put up with me because easily better understood. Directly you can make it connected to other resources. You can have a wire, now this day when wire also is not required. You can have a smart TV which has a built-in Wi-Fi and then you can stream content directly onto that or access using that small one more button on your normal TV remote. And then I have not seen anybody actually use the keyboard which is put on the thing. You have like so many numbers and selection of a thing and all that. No, maybe it is redundant. Eventually in the future, if you make your own what you call smart TV remote, probably a set of things, it may end up with your like a cell phone which has a nice beautiful flat Gorilla Glass screen, and then you can configure the buttons you want, including channels you want and all that, and including whether you want to switch between the what you call connecting it to the servers and all that, or you would like them stream them directly from the satellite, or in case you have a set-top box with a cable, that also can be used. You may be asking, is it not the same? No. Satellite does not come when it's raining, and set-top box with cable even now works reliably, and it's a little cheaper than they call this thing. So I have both of them. I can choose one of them. Now you see here, very important thing is this design stages. Downstream producibility with other design stages, not over the wall. When I say over the wall, it's not as if you freeze all the designs and then just pass it on, saying please take it on from here and then I'm working on the next project. Advantage here is simultaneously online, you and your design engineers, then the packaging people and down the production people can all work together. You understand? No, one side we have the hardcore design like this. So if you take, as I said, even if you take a normal thing like this mobile phone, I'm surprised at the type of features it has come out with. So many antennas, except that wireless charging, all of them seem to be, at least I am able to use all of them. And another thing a little related, it has caught on and not yet fully caught on is NFC. At one time when NFC started, they showed us a phone. You show the phone or walk near a Coca-Cola vending machine or else any cola vending machine, and then automatically you can get the cola, and then for some time at the same price as you would get in the retail. I thought it was a very good system, but then it didn't take off as I expected it. So when I walk by the machine, nothing happens. Next thing talks about normalization, standardization, value engineering. So I couldn't find a better word, because standard talks about how two things don't fit. So we have a parallel and second parallel standards. Normalization talks about how to make everything about as flat as possible. I cannot define these terms, but expect that within your enterprise and within your area of expertise, features versus cost can be optimized. Nobody really wants to buy a cheap anything. Anything inexpensive is probably cheap. Cheap, even semantics indicate that it is unreliable. If you can afford an original watch, you will buy it. I don't think you will buy a replica, and definitely you will not buy a cheap look-alike. Value engineering instead talks about trying to offer features at a reasonable value. Next we come to a very important thing, prototyping. If you start your design in a CAD format, prototyping appears to be very, very, very easy. So in case you want, you can use sheet metal. In case you want to use some polymer or plastic sheets, you can use it there for laser cutting. And in case you want to do 3D printing, you can go ahead and use it for rapid prototyping. Then in case you want to send it for the machine shop with CNC machining, you can do it. And things which I have not mentioned earlier, including spark erosion and wire cut electro discharge machining, all of them, inputs to that can be seamlessly brought in from here. After having worked with this for around 25-30 years, I seem to enjoy these things. I am sure each of you have your own reasons for picking it up. One of them is the primitives that we use are intuitive. So a line is called a line, and then of course a circle is called a circle, and an ellipse is called an ellipse. Now we come to the other beautiful other things. Suppose you take an ellipse, you take the minor axis and rotate around it, you get an oblate spheroid. Suppose you take the major axis and rotate about it, no, you get a different spheroid. It looks like a so-called classical American football. These are all, to me, this looks very intuitive in producing things. Now you can always build very complex entities using basic lines. You have two lines, you can, as I said, in space 3 points can be located in space, and a single triangular plane can go through those 3 points. And this is the starting point for all mesh and including hyper mesh. So from basic lines you can contain surfaces. As I have told you last time, you can take a flat thing with 4 corners. If you bend it, fold it around one of the diagonal edges, it will be 2 triangles. Next comes, if you see any CAD package, one of the first thing you will notice is there are so many unexplored features which we didn't know could be useful. So 2 ways of looking at it is, one is I want to do something and how to do it. Another is what is the tool which I have now, what all can it be done, and then there are always patches. Another thing is selecting of objects on the screen. So most of the current thing allow you to select only certain features there. Certain of them can be locked, and when you lock them, everything does not get selected, the position is locked. Something which I like, which as I said, no, what gets my attention is the concept of layers, which to me is a godsend, which we could not do earlier. So what is presented on the screen is actually something nicely flatly merged features which are there. So in case I want to have a mounting holes, 4 of them can be kept in one layer. I can switch it off, keep it there and so on, or keep it locked it such that I cannot search for it. The same thing can be used with the printed circuit board, the machining thing, as well as the enclosure design which I am trying to do. So it's perfect, and once I fix dimensions also of it, easily can be fixed. Something very much related to this is various types of attributes of these entities. Simplest thing which I can talk about is a line. We have to work backwards. We still have to make projection drawings which look little like what was there earlier. So things like can easily convert it into a dotted line. And if it's a line of symmetry, usually we call it an axial thing that has its own representation. All these can be made easily. A little related to this is how they appear on the screen, the color of the particular thing, and then something related to layers and all that. As you see in the next thing, I will try to show you something related to the layers and all that. You can make some of the features take the color and attributes of the layer on which they are, or separately on this. So when you look at the color of let us say some outline, you will know automatically which layer it belongs.